Hello everyone. In this lecture I shall discuss the Fourier series, basic formula on Fourier series and the convergence behavior of Fourier series. The basic concepts I will tell. Now if you recall the differential calculus, we are familiar with the Taylor series expansion. Every differentiable functions, continuously differentiable functions can have a Taylor series expansion, right? You know every differentiable function is continuous. So once it is differentiable means continuous is by default, right? However, there are many discontinuous functions of which we are not able to find the Taylor series, right? Moreover, if the functions are periodic, right, then we can have the Fourier series expansion, but do not have the Taylor series representation, right? So Fourier series are more universal in the sense that many discontinuous periodic functions of practical interests can be developed in terms of Fourier series but do not have the Taylor series representation. Now in continuation to the previous lecture where I have discussed the details of the periodic phenomenon, right, and the Fourier series arose from the concept of vibration of string and the conduction of heat. So here there is the wave, right, and sine and cosine functions being the wave functions. Fourier series are expressed in terms of the trigonometric series expansion, right, known as the Fourier series expansion. So the periodic functions have the Fourier series expansions. So let me write the formula for the Fourier series. Let f belongs to L minus pi pi. So here L stands for the Lebesgue integral. The function is integrable in the interval minus pi pi, or it may be written as L of c to c plus 2 pi, right? If I put c is equal to minus pi, then it can be generated, right? So it is a general one. Or in particular, if I have suppose L of 0 to 2 pi, or I have suppose my L of minus pi by 2 to 3 pi by 2. You see, this is more general because if I set c is equal to 0, I will get it. If I set c is equal to minus pi, I will get it. If I set c is equal to minus pi by 2, I will get it. Is not it? So this is a general approach, right? So once the function is defined over the interval, whatever it may be this or this or this or this, right? And these are all be, what is the length of the interval in each case? What is the length of the interval? The length of the interval is 2 pi. What is the length of the interval? Is 2 pi. In general, it is a 2 pi periodic function, right? Be 2 pi periodic. Then its Fourier series expansion is given by f of x is equal to, right, a0 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx. If I open it, so it will be my a0 plus putting n is equal to 1 2 3 so on, a1 cos x plus a2 cos 2x, a3 cos 3x plus so on, and similarly here plus b1 sin x plus b2 sin 2x plus so on. You see, the left hand side is a function, however the right hand side is an infinite series. So how a function is equal to an infinite series? That's why I write this approximately same, right? So now this equality will be ensured subject to the convergence condition, right? Now this sign is replaced by the equal sign subject to the condition, the series is convergent, okay? convergence. I will discuss it later on. So now this is the Fourier series, right? So this is the Fourier series expansion of a 2 pi periodic functions. So here you see a0, an and bn. We need to determine these things. Okay, these are called the Fourier coefficients. So I write where a0, an and bn are Fourier coefficients. Of course, prior to Fourier, the approach has been made by Euler. So it is correct to say jointly Euler Fourier coefficient. It will be more appropriate, right? Euler Fourier coefficient given by. So before I write the formulas of A0, An and Bn, let me to introduce myself. Professor Susanta Kumar Paikray, S.K. Paikray, currently working as a Professor of Mathematics at Burla, Sambalpur, Odisha, India. Okay. So before we have the details of discussions, let me to tell you, in this lecture series, I have uploaded several lectures on engineering mathematics. So you should like and subscribe to this channel so that whatever the new lecture is uploaded, it will come to a screen so that you will not miss it, right? So all of you should subscribe my channel and like this video. Also recommend this video to your friends for the publicity of this video for their benefits. So now we need to find the value of the coefficients. Then we substitute this value to get the desired Fourier series. So what is my A0? A0 is here 1 by 2 pi. Suppose I am taking the interval. Suppose I am taking this interval. Okay, minus pi to pi. Then I will take the limit from minus pi to pi. If this interval will be given, I have to take the limit from 0 to 2 pi. If this interval will be given, I have to consider the limit from this, or in general I have to take the limit of this, right? In particular, I am considering here this interval. I am considering this. Okay, so it will here fx dx, right? And what is your an? Here an will be 1 by pi integral minus pi to pi f of x cos nx dx, and your bn will be 1 by pi minus pi to pi fx sin nx dx. So now these are called the Euler Fourier coefficient, and basically these are my Euler's formula, right? Euler's formula. That's why this is called the Euler Fourier coefficient, right? Euler Fourier coefficient. So now our job is we find this Euler Fourier coefficient and we just substitute these values A0, An and Bn, and this will be my final answer. And the convergence analysis I will study later on. I will tell later on. Okay, but first we will learn how to find the Fourier series. Okay, so now you see this, once the function is even or odd, then this Fourier series will becomes easier. So let me to tell you what is an even and odd function. Now if you recall even and odd nature of the function, right? Just you recall even and odd function. You know, integral minus a to a, right? A to a fx is equal to twice 0 to a fx dx, right? If f is even, and it is 0 if f is odd, right? So you see, since it is minus pi to pi, it behaves like minus a to a. So now this even and odd nature of the function will affect these coefficients. So how to find even? Even means here f of minus x is equal to fx. Odd means here f of minus x is minus of fx, right? For example, sine of minus x is minus sine x, is an odd function, and here cosine of minus x is cos x, is an even function. So this odd and nature of the function will bring this formula of the Fourier series simple. You see, if the function is odd, right? Case 1, if fx is equal to odd, what will happen? If this fx is odd, what will happen? You see, once it is odd, then this will 0, this a0 will 0, is not it? a0 will 0, and this is here, cos is a even function, and once this is odd function, right, then odd into even is odd function, so here an is 0. So sine is an odd function. Once fx is odd into odd is even, right, even. So this minus pi to pi will be replaced by 2 into 0 to pi. So this here bn is equal to 2 by pi 0 to pi fx sine nx dx, right? So now what will happen to your Fourier series then? So therefore your f of x will be only summation n is equal to 1 to infinity bn sine nx. Is that not simple? So this is here b1 sine x plus b2 sine 2x plus b3 sine 3x, so on. So this is your Fourier series for odd case, right? This is your Fourier series for odd case. Clear? Is that not simple? Right? So now likewise, if the function is here even function, then what will happen? Right? If the function is a even function, then what will happen? You see, suppose your fx is equal to even, right? Coming to your case 2. If fx is equal to your even function, what will happen? You see, what will happen? In case of the even function, once this is even and this is your odd, so even into odd is odd, so this bn will 0, right? What will happen? Here bn will 0, right? And what will happen here? Once it is even, this becomes here 2 into 0 to pi. So what will happen to your a0? a0 will be here 2 into 0 to here a0 was earlier 2 by 1 by 2 pi, so it is 2 by 2 pi, right? Means here 1 by pi 0 to pi fx dx. And likewise here an is equal to what? You see here an 2 will be multiplied, limit will be 0 to 2 pi, 2 by pi 0 to pi here fx cos nx dx. So now if you substitute the value of a0, an and bn, what will happen to your Fourier series now? So therefore, once the function is even, your Fourier series becomes here a0 plus summation n is equal to 1 to infinity an cos nx. Okay, so is that not simple, right? So the simple even and odd nature of the function will bring your work simple. But however, the test of even and odd is another separate aspect, depends upon the nature of the function based on the graph and the given interval. And in a subsequent lecture, I will tell details about the odd and even nature of the functions. Now one more information I have to tell here. In some books it is written here, half a0, and accordingly once it is half, okay, so this 2 is omitted here. So don't be confused with this formula, right? But we will move in this way. will move in this way. It is here a0, accordingly it is here 1 by 2 pi. Okay, we'll write like this. So don't be confused with those formulas. Okay, so now let me to solve few problems. Suppose consider one example. Example 1. You are asked to find the Fourier series expansion of, okay, find the Fourier series expansion of f of x is equal to x, 0 less than x less than 2 pi. Okay, so you see this is a 2 pi periodic functions and it is integrable from 0 to 2 pi. So in that way we write solution. Let fx belongs to L 0 2 pi be 2 pi periodic, so its Fourier series is given by f of x is equal to a0 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx. Okay, so to find a0, what is your a0? Your a0 is equal to 1 by 2 pi integral 0 to 2 pi fx dx. So this is equal to 1 by 2 pi, here 0 to 2 pi, the function is x dx. So this is equal to here 1 by 2 pi integration of x is x square by 2, 0 to 2 pi. So this is 2 pi whole square by 2 into 2 pi. So this square and 2 pi cancelled. So this is your pi. So this implies here a0 is equal to pi. Then we find an. To find an. So what is your an? An is equal to 1 by pi integration of 0 to 2 pi fx cos nx dx. So the value of fx here is, it is 1 by pi integration of 0 to 2 pi fx within this interval is x cos nx dx. So we apply integration by parts here. Okay, we apply by parts rule here, by parts rule of integration. So what we will get? It is 1 by pi. If you integrate it, my first function remains silent. Integral of second is your sin nx divided by n. Put a negative sign. Derivative of the first is here 1. Integration of the second is minus cos nx divided by n square. Okay, so directly applying by parts we will get it. So now you see sin n pi is 0. Okay, sin n pi is here 0. So this function will 0, right? This function will 0. So it is only reduced to this function. This limit is 0 to 2 pi. So here, see here, it will be, it is minus plus, so it is 1 by pi n square. Only here cos nx 0 to 2 pi, right? So this will be 1 by pi n square. Here cos 2 n pi minus cos 0. You know cos n pi is minus 1 to the power n, right? So your cos 2n pi is minus 1 to the power 2n is here 1. This is also here 1. So this is here 0. 1 by pi n square into 0 is 0. So therefore your an is equal to 0. Now to find bn. What is your bn? Bn is equal to 1 by pi 0 to 2 pi fx sin nx dx. So this is here 1 by pi 0 to 2 pi fx is here x it is sin nx dx. So we apply by parts rule here, right? What we are getting, so this is 1 by pi x integration of sin is minus cos nx by n. Put a positive negative sign here, derivative is 1 and integration of this is minus sin nx by n square, right, from integration 0 to 2 pi. Now you see sin 0 0, sin 0 0, sin 0 0 and sin n pi 0. So this will 0, only this integral will persist. So this will give you, now this 0 will not work because 0 into something is 0. So only this is minus of 1 by n pi. It is cos, it is 2 pi, putting x is equal to 2 pi, it is 2 pi cos 2n pi. Now the value of cos 2n pi is 1, right? Cos 2n pi is minus 1 to the power 2n is here 1. Okay, so this will give you pi cancelled, it is here minus 2 by n, minus 2 by n. So therefore what is your bn? Bn is minus of 2 by n, right? So what is the Fourier series then? So now you substitute the value of bn, a0 and your an, a0 and an, substitute in equation number star. Let this be my star. Okay, now equation star follows, right? Now equation star follows here fx is equal to a0 is your pi plus bn, an is 0, summation of n is equal to 1 to infinity, an is 0, bn is minus 2 by n sin nx, is not it? So this is equal to pi minus 2 by n here sin nx, summation of, so it is 2 1 by n sin nx. Now if you open it, it is pi minus 2, it is sin x 1 by 1 sin 1x plus 1 by 2 sin 2x plus 1 by 3 sin 3x plus 1 by 4 sin 4x plus 1 by 5 sin 5x dot 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 dot. Okay, so this is my answer here. Now if we think of this convergence behavior of this, right, convergence behavior of this, right? So now if I put suppose here x is equal to pi by 2, then what will happen? Putting x is equal to pi by 2, we find f of pi by 2, f of pi by 2 will be here pi minus sin pi by 2 is 1, so this becomes here 0, this becomes here 0, so sin pi by 2 is here 1, it is 2 into, it is 1, and sin 3 pi by 2 is minus 1 by 3, and it is plus 1 by 5, because here sin n pi by 2 is minus 1 to the power n minus 1 by 2, n is equal to odd, and 0, n is equal to even. So this formula will be applied over here. So what we are getting, what is f of pi by 2? F of pi by 2, f of x is equal to your x here, f of x is equal to your x, right? So f of pi by 2 is your pi by 2. So this means, that means here pi by 2 is pi minus 2 into 1 minus 1 by 3 plus 1 by 5 minus dot dot dot. So now bringing this, it is minus pi by 2. So minus pi plus pi by 2, minus pi by 2 is minus 2 into 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 dot. So now bringing this minus 2 to this side, what we are getting? 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus dot dot dot, bringing this to this side, it becomes here pi by 4. So what we are getting? We are getting, simplify this series, okay, simplifying the Fourier series, find the Fourier series expansion of this and deduce 1 minus 1 by 3 plus 1 by 5 minus 1 by 7, so on is your pi by 4. Okay, so you see, so this will generate the sum of the infinite number of terms, okay, and giving to this value, right? So this is called the convergence, means it at pi by 2. So at pi by 2, right, here fx, the Fourier series will converge to pi by 4, right? So this type of things we will discuss in convergence behavior, when the Fourier series will converge, right? When the Fourier series will converge to a exact function, right? It is at a particular point, right? So this convergence is followed by the Dirichlet conditions. I will tell the Dirichlet conditions, okay? So the convergence of Fourier series, right? Convergence of Fourier series is accompanied by the Dirichlet condition, Dirichlet's condition, right? Now what is Dirichlet's condition? A function fx is said to satisfy the Dirichlet's conditions. Dirichlet's condition if it has the following properties. 1. The function must be single valued, right? A function fx is single valued and finite in a given interval, okay? Second condition is fx is 2 pi periodic, right? Third condition is fx has finite number of discontinuities. Suppose fx is single valued and finite in a given interval. You say in general c plus 2 pi, whatever it may be. Then fx is 2 pi periodic. Fx has finite number of discontinuities in that interval, right? In that interval. And fourth point is fx has at most finite number of maxima and minima. Fx has finite number of extremas, maxima and minima, means extrema, right, in c plus 2 pi. Now if these four conditions hold, fx is single valued and it must be finite, it should be 2 pi periodic, and it is a piecewise continuous function having finite number of jumps, and fx has maxima minima, finite number of maxima minima, or we can say at each point, right, left hand derivative is equal to right hand derivative, right, at each point it can be replaced by this also, right, or fx has finite number of extremas. Now once this Dirichlet condition holds, then the Fourier series will converge to the function at the point of continuity. So let me to write the convergence criterion. So the convergence criterion, if fx satisfy the Dirichlet condition, then the Fourier series of fx, right, converges to the same function fx, to fx itself at the point of continuity. Moreover, at the point of jump discontinuity, it will converge to the average of left hand limit, right, and right hand limit at that point, and right hand limit at that point. In particular, suppose you are given a function, fx is equal to minus x, minus pi less than x less than 0, plus x 0 less than x less than pi. You find the Fourier series. Suppose we have the Fourier series, you obtain fx is approximated by the Fourier series a0 plus summation an cos nx plus bn sin nx. So what will happen? Right, at any point in between this, it is a point of continuity. Any point in between this, it is a point of continuity. Right. So for x belongs to minus pi 0, right, here fx converges. The Fourier series of fx converges to fx itself, right. Similarly, for x belongs to 0 pi, the Fourier series of fx converges to fx itself, right. So this is about the point of continuity. But what will happen at 0, say 0 is a jump here, right. So the Fourier series of fx converges to, right, average of half of, right, limit x tends to 0 plus fx, right, 0 plus fx plus limit, it is 0 minus, this is 0 minus fx here, left hand limit, and limit x tends to 0 plus fx, right. So at the point of jump discontinuity, it is the average of left hand limit and right hand limit at that point. Right. So 0 is a discontinuity here, jump discontinuity. Pi is a jump discontinuity here, minus pi is a jump discontinuity here. So at the point of jump discontinuity, it should be the average of the left and right hand limit at that point. So this is what the Fourier series of a function, and the convergence criterion is followed by the Dirichlet's condition, right. And but this condition, convergence criterion, is followed by the Dirichlet condition, but this condition is sufficient only, but not necessary conditions. Even if this condition doesn't hold, still the Fourier series will converge, right. If in particular I say if fx is continuous CR-AB, continuous in this interval this, right, or in the interval 0 to 2 pi, then the Fourier series will dominate by summation of 1 by n to the power r, right. The Fourier series is dominant by this. So for r greater than 1, this will converge, right. Clear. So more about the convergence we will subsequently discuss. However, this condition is sufficient. Even if this will doesn't hold, still this Fourier series will converge, right. And another convergence criterion is this. This is basically the uniform convergence. So but at your level we should stick to the Dirichlet condition only, but this condition is sufficient. Even if this condition cannot hold, still we may have the convergence of the Fourier series, or we may not have also the convergence, right. So now the solutions. So solving the problems needs some basic trigonometric formula, right, basic trigonometric formula and basic integral formula. In the subsequent lecture I will tell, but at this juncture I will tell you some simple formula which will help you to solve the Fourier series problem easily. Suppose I ask what is sine n pi is 0 for all n, right. Sine n pi by 2, it will minus 1 to the power n minus 1 by 2 if n is equal to your odd, and 0 if n is equal to your even. Similarly, what is cos n pi? Cos n pi is here minus 1 to the power n, means minus 1 n is equal to odd, and 1 n is equal to even. What is cos n pi by 2 is equal to minus is 0, n is equal to your odd, minus 1 to the power n plus 4 by 2, n is equal to your even, right. Similarly sum your trigonometric orthogonality property. Here minus pi to pi, right, minus pi to pi. Here sin mx into sin nx, sin nx dx is equal to 0, right, m not equal to n, pi, m equal to n. Similarly here minus pi to pi or 0 to 2 pi, it is cos mx into cos nx dx is equal to 0, m is not equal to n, pi, m is equal to n, not equal to 0, right, and it is 2 pi, m is equal to n equal to 0. It is not equal to 0, and it is minus pi to pi sin mx into cos nx dx is equal to 0 for all m and n, right. And similarly we have the integral formula, e.g. we have by parts. Okay, these things we have to review, then only these problems are simple. Okay, so the video is getting lengthy, we should close the lecture here. Before I closing, one more time I appeal to all of you is that if you feel this lecture is helpful and interesting, please like and subscribe to this channel, which will boost my motivation to upload subsequent lecture. Thank you all.